welcome back. How are you doing? It feels like forever since we were last here. And Anna, if you do me a favor, you see the edge of the projection? If you can just slide the projector that way until it lines up with the black line. Perfect! You're amazing. Thank you. All right, so we are going to do a little bit of a construction today. So if you don't have a compass and protractor, make sure you get that out. And you need to have cut out all of these little items. Finish that cutting if you haven't already. Bless you. I clearly need to finish because I was busy doing paperwork. Update your table of contents at this time. Please make sure that your title and objective get written down, please. And once again, for your convenience, I have included a title big enough for your notebook and small enough for your table of contents. So if you'd rather glue instead of write, that is always an option. I only have the one that I'm going to use right now, sweetheart. I'm so sorry. All right, so let's update our notes. It's been about a week since I touched this notebook. So I've got a lot of updating to do, and this will give you a good chance for you to see what notes you should already have in your notebook. All right, so we have this really ugly notes. That was from last week, Tuesday, and I now have a better copy of them, so my homework is replace that hot mess. Then you should have a KWL for that assignment. And then the next page would have been the midpoint revisited. Okay, so you should have the midpoint here. I haven't put that in, so that's my homework. It was 2 pages. Which means right here you should have a KWL for that one. And then the very last one was distance. It was only 1 page. So my homework is to make sure that gets in there. And again, we're going to have a KWL for that lesson. The next page after that KWL is one for the quiz that came from that section. This was the slope and distance quiz, and that was the one that you guys took on Tuesday, and you corrected in class yesterday for a progress report, which means today's lecture notes is going to start on the very next page. So if you have not done so already, please take a moment to update, page number, title, lesson codes, and objectives. I will begin in about 1 minute. All right, so some of you may have already seen the first run cut of the lecture that's for this up on YouTube. I didn't like it. I don't feel that I did a good enough job explaining things or giving all of the definitions that you might need. So I'm going to beg you to let me try again. So we're going to start with the definitions and then we'll right into the examples. This is going to feel like a normal lecture. First word that I want to describe for you is or define for you rather, is the word transformation. Have you heard this word before?
Mm-hmm. Yes.
What's it mean?
Words like you're sliding it or rotating it.
To change, to rotate it. What was the other one that you said? Slide it. Yeah.
Dilation, something like that.
Translate. Oh, you guys have a lot of really great vocabulary. Awesome. A change. And so I'm going to put some of those words that you've already said. I heard dilation. We had said translation. There was also rotation and reflection. Wow, you guys got.
Slide. Translation.
Translation. Transparent. Transparent means you can see through it. Yeah.
Like the
Jinx. Transparent.
Transparent.
Heard slide. What were some other things that y'all said?
Oh. ...
You guys are not wrong. We're going to be studying all of these different things and using them to draw pictures and describe points and things like that. Transformers, yeah, more than meets the eye. We're going to start with translation. I'm writing off the screen again. Don't worry, I'll slide it back to the left just a bit so you can see the rest. Translation is the first one that I want to start with. What was the translation?
Or slide.
A slide, yeah. A slide. Or a move in one dimension. Yes, sir.
You put slide twice?
Yeah, right here, right here.
No. Isn't the same thing translation and slide?
Yes, but we're defining what the word translation is, and we're using a different word to describe what it does. Okay. So I'm saying that it's a move in one dimension. It locks you into moving either left or right or up and down. You can't move diagonal with the translation. If you want to move in a diagonal way, you're forced to move either left or right first and then up and down, or the other way around. You move up and down first and then left or right. Okay? The order on that doesn't matter, but you can't just move diagonally. You've got to describe it in these dimensional kind of X or Y sorts of patterns. Okay? I want you to find the translation descriptions, please, and I want you to glue them into the very far left of your paper. Now, I know that we very rarely do any gluing in here, but this is where I want them glued today. Yep. All right, so let's look at our translation descriptions, and I'm going to zoom in pretty tight here so that you can see what's going on. So if we're moving horizontally, we're going to move side to side. So I want you to draw in a little picture of what horizontally is. And vertically is the up or down. So draw a little picture of the up or down. Now notice our four conditional statements here. If h is bigger than 0, then translate right. If h is less than 0, then translate left. If k is bigger than 0, then translate up. If k is less than 0, then translate down. Okay? So that's how we'll be describing in words these translations. I want you to take the lines that you used, the space that you used for this description, and I want you to cut it into 4 even pieces. Okay, let me zoom out here so that you can see it. Oh, out, not in. Hello. Cut it into 4 equal pieces like this. Okay. So this is the space just to the right of your translation descriptions. And in each one, I want you to please draw a little miniature XY coordinate grid. I don't have little cutouts for you on these. They would have been too small to see. So we're just going to draw them really quickly. X and Y. All right, so you have 4 little graphs. We're going to start here. We're going to put some dot on -10. and I'm going to translate it. When I'm done translating it, I'm going to zoom in tight here so you can see what I'm writing. When we're done translating, we're going to end up over here on positive 10. Which direction did we move?
Right.
To the right, to the right. How many units?
10.
We had to go from negative 10 to 0, so we moved 10. And then from 0, we had to move to 10. So how many more? 20. So we moved 20 units to the right. This means that H is 20. Now, notice in your translation descriptions, on the horizontal, when you're dealing with this left or right movement, we have this x plus h. H is 20, so if I were to substitute, I would get x plus 20. Now look at the value of h. Is h bigger than or less than 0?
Bigger.
It is bigger than 0. Nicely done. H is bigger than 0. Which means, what direction did we translate?
To the right.
To the right. You can see it, 1, physically on the graph with the arrow that I put, and 2, you can see it because the value of h is bigger than 0. Make sense? We're going to do the same thing on the next little graph. I'm going to zoom out just a little bit so we can see them both, because I know some are still copying. Okay, we're going to start over here on 20. And I'd like to move in this direction. And when I'm done moving, I want to end up on negative 40. What's the value of H?
60.
60. Is 60 positive or negative?
Positive.
Negative.
We have, okay. Tell me why it's positive, tell me why it's negative.
Because it doesn't matter how what direction it is, it's the same units, right?
Oh, because it's a distance.
Yeah.
Okay.
In a chart, isn't there like the negative and the positive on the side?
Yes.
So you can't, if it's a positive, you can't switch it to a negative. It depends on the number, like on the grid.
Okay.
And when you're subtracting 20 by 60,
Okay.
you get negative 40.
Okay. Ladies, unless the conversation's with us, have it later. Okay. So his argument, yes. His argument was that H has to be 60 because this is a distance. I'm traveling 60 units.
Dude, what?
That was his argument. That's why he's saying H has to be positive. But over here we're saying, yes, we're moving 60 units, but there's a direction involved. And in order to get from the number 20 to the number negative 40,
Yes, negative 60.
we have to subtract 60. And so the motion, this negative number that we add to it, implies that sense of direction, this left or rightness. Okay? Which means that x is less than 0. Look back at those descriptions. Look at that if-then statement. If h is less than 0, then translate left. Did we translate left here?
Yes.
And then h has to be less than 0. All right. Look at how we write this. The translation description for horizontal says x plus h. But what's the value of h? Negative 60. Now we have a positive and negative sitting next to each other. Does that hurt your brain? No. But it's a little bit, yeah. But it's not neat. It's not wrong. It's just not neat and tidy. And so we can transform this, rewrite it into x minus 60. Okay? Sounds good? And so we translated left. So write your translation left. Using this, can you see what might happen with the y's? We're going to take a moment to do the y's. I'm going to include the numbers and the motion, And you guys get to fill out the rest using the X as a template. All right, let's look at the first one under the Y. Which direction are we translating, up or down?
Down.
Down. Which means the value of X needs to, or K, excuse me, the value of K needs to have what relationship to 0? Greater than, less than, or equal to? Less than, she says. So K has to be less than 0. How far did you move?
Negative 50.
10 minus what
20.
gives you negative 30?
Negative
40.
Oh,
Wait,
negative 40.
Negative 40.
40, because you have to move 10 to get to 0, and then 30 more to get to 30. Very nice. Which means our expression is y plus negative 40, or y minus 40. They're both the same thing. All right, let's look at the next one. Which direction are we translating? Up, which means K needs to be?
Greater than
Beautiful. And what's the value of K?
15.
Negative 15. I know. Wait. 15.
15. You have to move 5 to get to 0, and then from 0 you move 10 more. So 15. And so the expression is y plus 15. So far, so good? All right, let's make this weirder and take it out of the realm of numbers, because the numbers are seeming really comfortable. And then we'll go back to numbers and it'll suddenly make a little more sense. All right, what I want you to do is I want you to take your protractor and compass.
Wait, can I use the next page? 'Cause I don't
Yes.
have-
Take your protractor and compass and I want you to draw a segment. Don't make it more than 3 of your spaces big. Okay? I don't care what size, I don't care what direction it's facing. Just draw a segment.
Alright.
Now, we've got this new little thing that I'm about to show you. And it's this guy. This little guy is called the transformation vector.
So that's supposed to be an H.
This? No, it's that. It's like an arrow, but it's missing one of the little arrowy things. This is called the translation vector. Have you ever heard translation vector before?
I've heard vector.
You've heard of vector. What is vector?
I remember playing the
A
game.
name.
A name. You've played the game named vector?
Oh yeah.
Yeah. So there's the little symbol, and it can be spun in any direction. You can put this.
Yeah, despicable.
Yeah, Despicable Me. Yeah, the guy in the orange jumpsuit. His name is Vector. Not Victor. It's Vector.
Their pajamas.
Yeah, their pajamas. Seriously? I thought it was just a tracksuit.
It is a tracksuit.
Nah, it's
It is a tracksuit. It's his pajamas. He sleeps in a tracksuit. All right, so this is the symbol for vector. Okay, and we can spin it in all sorts of different directions. Okay, and what a translation vector is, on top of the guy in the orange jumpsuit in Despicable Me.
Who's that? Oh, vector. Oh, that's
my
vector,
God.
isn't it?
Oh yeah.
No, his name is Vector.
It's Vic. Oh.
It's Vector.
What is that too, Miss?
Vector
Right?
even said it.
Mrs.
It
I
is.
don't
Wait,
need to get mad.
I'm
It
waiting.
is.
I'm waiting. A translation vector is a ray
Ace. Oh, I can't
that
say.
gives direction
There, there's its own-
and distance. So this translation vector tells me take this line and move it that way, that far. And notice now there's no numbers. All right? Okay. So I want to move it this way, this far. I'm going to name this translation vector. Give me a letter.
B.
B, I heard. Just like with lines, we're going to use lowercase cursive letters. So there's my lowercase cursive B. And then I need to draw the little vector symbol above it.
Can I just draw the regular B?
It has to be cursive.
Oh, that's not cursive.
Do your best.
Dude, we did like a whole worksheet of cursive.
I'll bring out some more soon. I know it gives you an easy... Mañana? I'll see. I'll try. It's okay. We'll get you better. It's okay. We'll get you better. All right, so there's our vector B. And we're going to translate this line. I need the name of these 2 points. J and L, I heard. So we're going to translate JL by vector B. Here's how we do this. We're going to use compass and protractor to make this work. We're going to construct congruent segments, but we're going to use this segment as the congruence.
Mine's all tiny.
Yeah, mine too. I should have thought this through more. I should have. All right, here's what we're going to do. We're going to take this distance, and we're going to copy that distance as a circle at each endpoint. Okay? Oh my goodness.
Oh my god.
My compass is moving.
You see how that happens to me, miss?
Yep. Oh,
See, it gets frustrating.
it does. I get it. I am right there with you. But we're going to do our best. Hold your tongue the right way so that it works.
My tongue?
Look, it worked.
That looks like an oval.
Okay. We're going to do the same thing to L at point L. Okay, hold your tongue right. Ready? Are you holding your tongue right?
Miss, mine like flew off.
Mine too. It's okay.
Oh, my pencil's not even touching the paper.
That's how far we need to move each point. Now we've got to figure out in which direction. Because the property of this circle is that every point on the outside of the circle is the same distance from that middle point around which we spun our compass. So we know how far we're moving, but we don't know in what direction. Do we? Not really. Because it's being projected.
And plus she has wider.
And I've got a really fat pencil on my compass today. I did not sharpen my pencil.
These pencils are stubborn.
They really are.
When you touch the thing, I'm
I like it to move it. All right, here's the next step. We know where the points, how far away the points are going to go. We need to figure out what direction they're going to go. Take a look at our compass, our vector radius real quick, and I'm going to zoom in really tight on the drawing, okay? All right. So there's my drawing. Shh, 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 shh. Language. I need to find some sort of reference, and I need some sort of angle. I'm going to use the fact that this is flush up against this line right here of my notebook paper. Okay? So I've got to figure out what this angle is right here. I can use congruent angles to do that. You remember your congruent angle constructions? All right, so let's do that. I'm going to make these rays big enough to deal with because they're really short. So I'm going to extend that one, and I'm going to extend this one. All right, I'm going to extend those two. We're going to construct a congruent angle because I want to copy this angle over here. So that way I know where this ray is supposed to go so I know what direction I'm heading. I know how far, I just don't know what direction yet. All right, so congruent angle construction asked me to take my angle and draw an arc. There's my arc. And then I'm going to mark off this distance. Oh, wait. Hang on. All right, there's this arc.
How big does it have to be, miss?
As big as you want. As big as what is comfortable. Now, this is my ray right here. This is my starting ray, this blue line of my notebook paper, because that's where I started it. Yeah. I know this is going to be weird. So right now, if you're feeling lost, just sit to watch, and then you can rewatch on the video and slow it down and play, okay? So I'm using this line right here as one of my rays of my angle, and I'm trying to find where this other ray that's holding my translation vector, I'm trying to find where it appears, okay? So I've marked off my reference angle, and now I'm going to mark off my congruent angle.
Wait, miss, what are you doing?
I'm doing construction of congruent angles, so I can find out where the vector is supposed to be.
I thought the angle was supposed to be in the middle of it.
I have this angle right here. I'm copying this angle. Everything's really small, and so it looks like it's on top of itself.
Everything's like I can see.
I can't make it any darker. All right, so now I'm going to mark off this distance because this is my reference ray that I created. Shh. And this is the ray that contains my vector. Taking that distance, I'm going to find where the arc that I created for my new angle intersects my reference ray. And then I'm going to mark off where it intersects the arc that I just made, which is somewhere right there, right here. And now I'm going to connect these two, but I'm going to use pencil. So my vector is along that line, but it stops here. So my vector is right here.
I don't get what you do.
What I did was I copied that vector. But I had to copy it exactly. I had to copy not only the length of the vector, but the angle in which the vector was traveling. You're going to have to watch it later, okay? Keep viewing here, and you can go back and rewatch it later. So you see the vector copied? This spot right here is our translated L prime. We have to repeat this for J. Okay, we have to repeat that for J. I'm going to show the repeat again. I have this angle already, so the only thing I need to do on J is to get my reference. So here's my reference ray. Here's me finding that distance for the congruent angles for my first marking. I'm centering it on J. Here's my reference ray, and I need to make it big enough to hopefully intersect where I want my vector to go. Grabbing this distance again, and again, this is the ray that's housing my vector. There's that intersection. And there's the intersection with the arc in my reference. I'm going to come to this intersection, my new reference and my new arc. And I'm going to mark where those two arcs intersect. And I'm trying to make it a little darker for you so that you can see it on the overhead. This is where those points intersect. And so my vector needs to lie somewhere on this ray. But it stops here because that's how big my vector was. So there's my vector. There is where J is going to end up, J prime. There's my new segment, J prime, L prime. I've moved J a little bit. Okay? Re-watch this section on the video a couple times, and I'll give you assignments soon that ask you to do stuff like this. And literally, I want you to just sit and get frustrated with it. Okay? Because that's the only way to make this work. I was frustrated the first like 20 times I tried to draw this. Yeah.
What's it called when there's two apostrophes on the letter?
Prime.
Double prime.
Double neg.
Yeah. This is just one prime. The other one's two Optimus primes. No,
What about
Jake?
3?
We won't get there. We won't get there. All right, I have some notation for you on the translation vector. And we're running short on time,
What time is it?
and I have to get to the next one. So if I can ask for your attention so we can get through it. The notation for a translation vector is like this.
What is notation?
Notation means how it is written. It is written this way. They look like parentheses, but they're sharp and pointy. Don't touch them, they hurt. Ow. Yeah, it poked me. HK.
Oh, yeah, fine, yes.
Put it away. Put it away. All right, gonna zoom out. I'm out of room on this page, so I need to go to the next page. Oh, it's just the notation.
There you go. Wait, I'm watching the video.
Miss, I was wondering if when we're done, you could go over the second.
Sure she cannot.
The second, which one?
Like, you measure from the.
Yeah, if there's time. Yes. All right. For this example, I would like you please to find the graphic that has the coordinate points marked down for you. Get it glued in. And what we're going to do is we're going to draw the translation. And here's some chatter in the back. Thank you very much. Left 6, down 7. That's the translation I would like to draw on this picture. I need to name this thing first. Can I have 2 letters, please?
B.
B and J. There they are. All right. We're moving which direction?
Down. 7.
Left 6, down 7.
Yeah.
Or down 7 and left 6. The order doesn't matter. The numbers do, but not the order.
Or left 7, down 6.
No, that you cannot do. We can't mix this direction with this number. They're locked together. All right, so do that. Take a moment, and each one of these points here, move it to the left 6 and down 7. So I'm going to zoom in really tight on my graphic. Whoopsie, I'll pick it up later.
Let's be careful.
Okay, thank you. Left is this way. Alrighty, here we go. Left 6, down 7. 1, 2, 3, 4, 5, 6, and down 7. 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to do the same thing to J. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So here is B prime, J prime. And I'm going to take my protractor and I'm going to draw the segment.
We do it again with 6.
6 to the left and 7 down from each point. So I started at B, counted 6 this direction, stopped, and then counted 7 in this direction. Wherever I ended up, that's where I put my points. Bless you.
And this one too, right?
And we're doing the same thing with J. Where?
On the side, draw what?
Draw the translation. We only have 9 minutes left in class. Ladies. I'm not quite done. All right. So we went to the left 6. Is this an H thing or an K thing?
H.
It's an H because left or right is horizontal.
Yes, ma'am.
What is the value of H? 6.
6.
But we went to the left. Look back at your descriptions.
-6.
Is it bigger than 0 or less than 0?
Less than 0.
-6.
-6. It is a less than 0 thing. All right, let's look at the down. The down must be K. All right, we're moving down. Is that an up or a down? It's a down,
It's
obviously.
Yeah,
Down. Greater than 0 or less than 0?
Less than 0.
Less than 0, so negative.
7.
7. That's what we expect. Let's confirm this. What are the coordinates of B prime? -7,
-7,
comma,
1.
1. And J prime, what are my coordinates?
-1, 5. -5. Or 5.
-5. You're right. So there's our coordinates. I'm going to look at just the translation of B. Here are the coordinates of B prime. And here are the coordinates of B. Oh, goodness, I used the wrong coordinates.
Oh, miss, I'm writing a pen.
So am I. Sorry, I grabbed the coordinates for J. All right, there's the coordinates for B prime and B. -7, +1, and -1, 8.
Miss, you put B again.
What's the difference between B prime
Oh.
and B?
B prime is the translation.
B prime is the translation.
The number is
The numbers are different. When we're talking word problems, ladies, when we're talking word problems, what does the word difference usually mean to do? Subtraction. So if I ask what's the difference between these two, it's a subtraction. So let's go ahead and subtract them and see what happens. Here on our x, we're going to end up with -1 minus, -7 minus -1. We have a double negative here. Bless you.
Bless you.
How do I handle a double negative?
Positive.
Positive.
Turn it to positive. So I have -7 plus 1. What's -7 plus 1?
6.
It's -6.
-8.
Positive, -6. Excuse me. You're right. What was our K value?
It's -7.
Look at our K value.
-7.
Our H value, excuse me. I am all sorts of brain malfunction today, aren't I? I am. All right, let's do the same thing with K. We have 1 minus 8. 1 minus 8 is?
-7.
-7.
Oh, 7, yes.
What is our K value?
-7.
-7, not our H value. Do you see it?
Yes.
Yes.
All right, let's fix this one, glue it in, and we'll run the example another time. I need you to fix the axes because
X's.
Google Images fail. This is supposed to be the y-axis. This is supposed to be the x-axis.
Wow.
Rip. What happens when I go Google Images? Yes?
Excuse me, ma'am.
Yes?
Do you have Jorge de la Cruz?
Yes?
Will you send him to the office at your convenience?
Thank you.
Thank you.
There's the example. When we come back tomorrow, the quick example will be to work this through with a translation vector. Thank you very much. Bye.